There's a quiet moment in the night when the city's noise fades away and the sky opens up deep black, utterly still. You tilt your head back, watching distant points of light shimmer, and suddenly it hits you that light left its star thousands, millions, even billions of years ago, crossing an almost eternal void just to meet you right here, right now. In this instant, you stand on the thin edge between an infinite past and a fragile present, aware that your existence is only a fleeting heartbeat in the life of the cosmos. The universe we inhabit is about 13.8 billion years old. It's a number that sounds dry on paper, but carries a depth that can overwhelm even the wildest imagination. Picture the entire history of the universe as a colossal book so massive it would take a whole library just to hold it. Each page is an era, each line a million years, each letter a century. You turn thousands upon thousands of pages from the opening lines about the primal explosion through long chapters describing the first stars, swirling galaxies, newborn planets. Then, near the very end, in a nearly blank page, there's a tiny dot. That dot is the entire history of humanity, from our ancestors roaming the grasslands to this very moment as you watch this screen and listen to this story. If books aren't your thing, try another image. Imagine you're standing before a beach that stretches to infinity. Before you lies the ocean, an immense body of water reaching so far your eyes can't find the horizon. From somewhere far away, waves roll in, crash upon the shore, dissolve into white foam and vanish. Our lives, our planet's life, are like one small wave among countless others, brushing the sand only once before fading, while the ocean keeps breathing its slow, ancient rhythm. And like the wave, life doesn't exist on its own. It comes from somewhere shaped by invisible motions of the universe, by chains of cause and effect stacked over billions of years. Every speck of dust, every atom in your body, was once part of ancient stars that burned furiously and exploded, scattering the ingredients of life into space. They drifted, for millions of light years, gathered into planets, oceans, organic molecules, and eventually into you. Your story began long before Earth even formed, but the part you're aware of is just a brief melody at the very end of a symphony billions of years in the making. When we realize how small a part of the universe's story we occupy, two feelings often arise. One is the sense of being utterly insignificant, a speck of dust drifting through a sea of stars, nothing more, nothing less. The other is the opposite, that because this moment is so short, it becomes priceless beyond measure. After all, every sunset is beautiful, not because it lasts, but because it fades. If life is truly just a breath in the ocean of time, then perhaps that breath is the one thing that lets the universe know it's alive. There's a strange peace in that thought. We don't need to be the center of everything or to last forever to carry meaning. The moment you're living right now might be the only time in 13.8 billion years that these atoms, these thoughts, these memories have come together to make you. You're not just part of the story, you're a story entirely your own. But uniqueness carries its own question. If this is just a moment, what made it happen? Does the universe need us? Or are we simply an accidental byproduct of cold physical laws? Somewhere else, on another shore of time, are there other waves of life rising and fading? And if there are they looking up at their own skies wondering the same thing? Picture yourself sitting on a moonless beach at night. The water before you is pure darkness, but somewhere out there, waves are still on their way. You can't see them all, just as you can't know how many have broken before you arrived. But you do know one thing for certain: the wave at your feet will soon vanish, and all you truly have is this moment, this sound, this gentle touch of cold water on your toes. That fragile, complete feeling is exactly what life is in the current of the cosmos. Time doesn't care about our pace. It opens slowly, like a vast door, and closes without reason. And we caught between two infinities, a past we cannot touch, and a future we cannot see, can only look around and ask why we are here. Maybe the answer lies in the chapters yet to be written, or maybe it never existed at all. But the question remains like a faint echo from the deep sea. If we are only a moment, where did that moment come from? Who or what lit the brief stage light so we could step into it? And what happens when the light goes out? Let your mind drift far. We've only just opened the first door. There's something strange about cosmic time. It's not just long, it's so unimaginably vast that the human mind can barely wrap itself around it. We're used to thinking in days, months, years, and sometimes centuries. But once you step beyond the borders of our little planet, those units feel like trying to measure the distance between galaxies with a pocket ruler. From the Big Bang to today, the universe has been unfolding for 13.8 billion years. That number doesn't just dwarf our personal lifespans, it swallows the entire history of humanity. Every civilization that ever rose and fell, every light that has ever burned and gone dark in the night. Let's try a thought experiment. Imagine compressing the whole 13.8 billion years into a single calendar year. January 1st marks the Big Bang, the moment light first burst forth, when elementary particles danced in a chaotic ocean of energy. January passes, then February galaxies take shape, but Earth is nowhere to be seen. It isn't until early September that the solar system finally swirls into being under gravity's embrace. By late September, Earth cools, oceans form, and the first single-celled organisms set off on the longest adventure in history. In this cosmic calendar complex, life doesn't appear until mid-December. Dinosaurs stomp onto the scene on December 25th, only to vanish abruptly on December 30th. Modern humans, we arrive at 11:52 p.m. on December 31st, and everything we call history, the pyramids, the voyages, the wars, the symphonies, all of it plays out in the final seconds before the clock strikes midnight. Blink, and you'd miss our entire story. This perspective is both funny and unsettling. Funny because we like to think of ourselves as the main characters of the universe, yet in truth, our role is barely a last-minute cameo. Unsettling because it poses a deep question. If intelligent life emerged only in the final seconds, does that make us a natural part of the cosmic process? Or a strange accident? Scientists have debated this for decades. Some argue the universe is tuned for life, that from the very constants of physics, everything was set in motion, so that intelligence would eventually arise. Others say we're nothing more than the lucky byproduct of indifferent natural laws. From this view, if we never existed, the universe would carry on just fine. Stars would still burn, galaxies would still spin, there just wouldn't be anyone here to tell the story. What's fascinating is that both sides agree on one thing: time is everything. Without enough time, a planet remains nothing but a frozen rock. Without enough time, a civilization never learns to survive its disasters, natural or self-made, and vanishes before it can look up at the stars. And if intelligent life is still brand new in the universe, that might explain why we haven't seen anyone else. Time in this sense is like a vast field where only a few seeds ever sprout. Some fall too early when the ground is still frozen and never survive. Others fall too late when the sunlight is fading. We may be one of the rare seeds that landed at just the right moment, but that also means there could have been seeds before us. Somewhere in the deep history of the cosmos, another civilization might have bloomed, thrived, and withered away long before Earth was born. The thought is both thrilling and tinged with quiet melancholy. If they once existed, did they look up at their night sky and wonder like we do? Did they build brilliant cities, send signals into space hoping someone would one day answer? And if those signals are still drifting, crawling across millions of light years, will we ever catch them? Or have they already dissolved into the static of the universe? But the bigger question is, if we're so new, has someone already come and gone? Maybe they vanished like torn-out chapters in a book, leaving only scattered clues among the stars. Or maybe we truly are the ones opening our eyes beneath an empty sky, staring into a story that hasn't been written yet. And if that's the case, what will the next page say? Imagine you're standing alone in a vast field at night, the sky stretching endlessly above you, dotted with thousands of stars. The first feeling is awe, overwhelming and humbling. But then comes a subtle, sharp thought. If there are so many stars out there, and surely many of them have planets orbiting around, then why is it so silent? This simple yet profound question was famously voiced by physicist Enrico Fermi one afternoon in 1950, during a casual chat with colleagues at Los Alamos. 3 simple words. Where is everybody? And just like that, the entire search for extraterrestrial life suddenly woke up from its long slumber. Peeling back the layers, Fermi's question is both straightforward and unsettling. The universe is 13.8 billion years old. Unimaginably vast light takes billions of years to cross it. And if the laws of physics don't forbid intelligent life from emerging, then the odds that we're alone should be practically zero. Our own Milky Way galaxy alone contains somewhere between 100 and 400 billion stars, and most of those stars likely host at least one planet. Even if only a tiny fraction of those planets lie in the habitable zone, not too hot, not too cold, just right for liquid water that still leaves millions of potential homes for life. Now imagine this. What if an intelligent civilization arose millions or even billions of years before us? They'd have had plenty of time to develop technology far beyond ours, maybe even mastering interstellar travel. So why haven't we seen any signs of them? No radio signals, no probes, no colossal space structures, just the deafening silence of the cosmic void. There are many possible explanations, each opening a different window from hopeful to chilling. One idea is that intelligent civilizations are incredibly rare, a biological fluke that's almost impossible to repeat. Another suggests that even if intelligent life does appear, it rarely lasts long enough to become a cosmic neighbor. Civilizations might self-destruct through war, resource exhaustion, or disasters. They can't avoid asteroid impacts, supernova explosions, catastrophic climate shifts. In this scenario, intelligent life is like a brief flash of lightning against a dark sky, bright for a moment, then gone before anyone can see it. Another angle leans more psychological. Maybe they're out there, but deliberately hiding. Advanced civilizations might know that revealing their location is dangerous, like shouting in a dark forest where predators lurk. In a vast unknown universe where friend and foe are indistinguishable, the safest strategy might just be silence. This idea echoes the dark forest theory, described by author Liu Cixin, where every civilization is a hunter wary that revealing its presence might invite annihilation, so it chooses to stay hidden. Of course, there's a more optimistic possibility too. Maybe other civilizations are simply too far away for us to detect. Their signals might take hundreds of thousands, even millions of years to reach us, and by the time they arrive, they're so faint they get lost in the cosmic background noise. Or perhaps they don't communicate the way we expect. Humans rely mainly on radio waves, which are just a narrow slice of the electromagnetic spectrum. Maybe they use something we haven't even imagined yet, subtle shifts in starlight or quantum signals that our current instruments can't pick up. What makes the Fermi Paradox so captivating is that it's not just a scientific puzzle, it's a mirror reflecting how we see ourselves. If the answer is that intelligent life is extraordinarily rare, then our existence is something precious, almost sacred, and the responsibility to keep our own flame burning becomes a profound duty. If the universe is teeming with life, but we just haven't met anyone yet, then it's an invitation to open our eyes wider, improve our technology, and keep searching. And if the answer is that civilizations tend to destroy themselves before they can meet, well, that's a serious warning for our own future. In this sense, the Fermi Paradox feels like a message sent across time from unknown others, past or future. Be careful. Your time might be shorter than you think. Amid all these theories, there's one quiet, persistent thought. Maybe they're not silent, we just don't know how to listen yet. Perhaps messages are passing by us every day, but our limited senses and tools cause us to miss them. Like people living deep in a valley, hearing only the wind and running water, unaware that someone high up on the mountain is playing a melody not meant for human ears. So the question, where is everybody hangs in the void part, challenge, part whisper? And to answer it, we may need to learn not just how to observe, but how to truly listen to a universe we're only beginning to understand. Imagine a giant radio telescope standing alone in the middle of a desert, a kind of cosmic ear that listens silently, patiently, waiting for a signal. This isn't science fiction. It's the real work behind SETI, the search for extraterrestrial intelligence, a decades-long mission dedicated to catching even the faintest whispers from the depths of space. You've probably heard about huge observatories like Arecibo tirelessly scanning the skies for mysterious radio waves that aren't natural, but rather the footprints of intelligent life. The way SETI works is pretty straightforward in theory, but incredibly challenging in practice. Scientists use ultra-sensitive instruments tuned to very specific radio frequencies, because radio waves can travel millions, even billions of light years without losing much clarity. On top of that, they've expanded the search to other kinds of signals, like laser light highly focused beams sending out brief pulses that could stand out against the starry background. Signs of advanced technology might show up as unusual wave patterns or emissions that don't occur naturally steady radio frequencies, or repeating signals that make you wonder if someone is trying to send a message. But after all these years of watching and listening, no clear signals have turned up. That silence is startling and even disappointing to those who believe we're not alone in the cosmos. Vast swaths of frequency bands scanned hundreds of thousands of hours of data collected, and yet just empty echoes. Imagine standing in the middle of a vast ocean calling out to a friend, and all you hear is the sound of waves crashing at your feet. There are many reasons why the search is so tough and the results still so elusive. One of the biggest is timing. If civilizations only exist for brief moments in the grand timeline of the universe, the chance that two technologically advanced societies overlap enough to communicate is nearly zero. Think about it. Our universe has existed for almost 14 billion years, while a tech civilization might last just a few hundred or a few thousand years before fading away. The odds of two civilizations sending and receiving signals simultaneously are incredibly slim. On top of that, we don't even know if alien civilizations use the kinds of signals we're looking for. Maybe they communicate in ways modern science hasn't even imagined yet, using rare types of waves or technologies beyond our detection capabilities. Listening in a narrow frequency range is like trying to hear a single melody in a vast symphony, when you're only allowed to catch a handful of notes. There's also ongoing debate among scientists about whether we should be sending signals out at all. Broadcasting might attract unwanted attention, hostile beings somewhere out there, a chilling idea known as the risk of alert. This adds caution to our search, creating a tension between the desire to reach out and the fear of being discovered. So the silence we encounter doesn't necessarily mean the universe is devoid of intelligent life. It might simply be the quiet passage of time, a cosmic coincidence, that our histories don't align, or the limits of our own technology and understanding. And then the next haunting question arises. Why do civilizations seem so fleeting? Is it a universal rule for intelligent life, or just a tragic coincidence? That could be a whole other story, one richer and more mysterious than we can yet imagine. Imagine that the path to intelligent life and the ability to travel between the stars is not a smooth, straight highway. Instead, it's more like navigating a vast, treacherous maze filled with hidden traps where any wrong step could lead to an insurmountable obstacle. This is the heart of a concept known as the Great Filter, an idea developed to explain why intelligent life, though theoretically possible throughout the universe, seems so incredibly rare that it leaves us wondering. The Great Filter theory was put forward by researchers searching for life beyond Earth. It suggests that there are natural, or maybe even self-inflicted filters along the evolutionary journey, from simple organisms to advanced civilizations capable of spreading across planets. These filters might be extremely tough. Biological leaps, relentless environmental catastrophes, or risks created by intelligence itself. If you look back at Earth's evolutionary history, you'll find countless critical moments where life had to overcome monumental challenges just to survive. Take the leap from single-celled to multi-celled life, a huge evolutionary hurdle, or the emergence of creatures with complex consciousness and intelligence. These breakthroughs might be incredibly rare, and on other worlds, the right conditions or sheer luck may never line up to allow them. Another aspect of the Great Filter is environmental hurdles. A planet needs stable conditions, the right temperature range, a protective atmosphere, and a steady energy source for billions of years, things we take for granted on Earth, but that are actually quite fragile. Entire biospheres could be wiped out by asteroid impacts, nearby supernova explosions, or extreme climate shifts. But even if intelligent life does arise, it doesn't guarantee survival past the challenges it brings on itself. Threats like nuclear war, human-driven climate change, resource depletion, and technological hazards could wipe out a civilization within centuries or millennia. This raises one of the hottest debates in science today. Is the Great Filter behind us, meaning we've already survived the hardest steps? Or is it still ahead, lurking in the unknown future? If the Great Filter lies in our past, it means the toughest hurdles from the dawn of simple life to the rise of human civilization have already been passed. In that case, our existence is a rare and precious sign that the universe can indeed produce complex, intelligent life. But if the filter is still ahead with dangers we don't yet understand or aren't prepared for, the outlook grows much darker. The story of the Great Filter isn't just a dry scientific theory, it's a profound reminder of how fragile life is and how delicate our place is in this vast, unpredictable universe. It forces us to ask, do we have the wisdom to face the challenges that lie ahead? To get closer to an answer, we have to go back to where it all began, where life first took root and the evolutionary journey started. Together we'll explore these early stages and uncover the key turning points that may have acted as crucial checkpoints determining just how far life can go. About 2.4 billion years ago, Earth wasn't the planet we know today. Its atmosphere was almost completely lacking free oxygen, and life existed mainly as tiny, simple microbes quietly swimming in the primordial oceans. This period marks a revolutionary turning point known as the Great Oxidation Event, one of the most crucial moments in the history of our planet and life itself. Before this event, Earth's atmosphere was dominated by gases like methane, ammonia, and other compounds, creating an environment vastly different from the oxygen-rich air we breathe now. Then a humble group of bacteria called cyanobacteria began a process called photosynthesis. Using sunlight, they converted carbon dioxide and water into energy-releasing oxygen as a byproduct. Though it sounds straightforward, the appearance of free oxygen sparked a massive biological and geological upheaval. Oxygen is highly reactive. It can break down many organic compounds and was toxic to many ancient microbes adapted to an oxygen-free world. As a result, many early organisms either vanished or had to adapt, triggering what's often called the oxygen crisis in life's early chapters. But oxygen's arrival also opened the door for more complex life forms to evolve. Because oxygen supports more efficient metabolism, organisms could generate more energy, paving the way for multicellular life animals and eventually intelligent beings like us. Interestingly, this transformation didn't happen overnight. Oxygen didn't flood the atmosphere all at once. It accumulated slowly over millions of years like drops of water filling a vast lake. The Great Oxidation Event shows us that life's story isn't just a rapid march forward, but a long, gradual dance of change, shaped by natural events and biological hurdles. A lesser-known detail is that before oxygen became abundant, some bacteria relied on molecules like sulfur or iron for their metabolic processes. This created an ecosystem very different from what we see today. The oxygen-driven shift nearly wiped out those ancient life forms, but also laid the groundwork for the rich diversity of life we now enjoy. Scientists still debate the exact causes and details of how this event unfolded. Some argue it was a sudden biological breakthrough, while others think it resulted from geological changes like continental drift or a drop in methane emissions. The variety of theories highlights how the Great Oxidation Event remains one of Earth's greatest mysteries. More profoundly, This event teaches us that life isn't just a passive passenger of its environment. It has the power to shape and transform its planet, albeit over billions of years. This is an important lesson when we reflect on our own existence in the vast cosmos. If you look closely, every major leap in life's journey demands patience and time. Breakthrough biological changes rarely happen quickly or easily. Even now, living in an era of scientific marvels, we are but a tiny part of the universe's endless timeline. And if it took billions of years with countless challenges and surprises to shape a planet like Earth, then the big question remains: how much longer will we endure in this grand story? Do we have enough time to keep evolving, expanding our understanding, and maybe one day break free from our planetary cradle? Or are new challenges and unknown filters still waiting just ahead? The story of the Great Oxidation Event is more than a chapter in science. It's like a poem of time, inviting us to pause, listen and reflect on perseverance, the deep bond between life and planet, and the mysteries the universe has yet to reveal. Imagine the universe as a vast stage where actors appear and vanish in brief, mysterious scenes. Life, though it might exist in many places, doesn't always get the chance to shine. In reality, life can only thrive within what we might call biological windows, those rare limited periods when conditions on a planet or within a star system become just right to nurture and sustain complex life. We're familiar with the idea of the Goldilocks zone, that sweet spot, where a planet isn't too hot or too cold, not too close or too far from its star, creating an environment just right for liquid water and life to flourish. But that's only part of the story. The Goldilocks zone isn't just a spatial concept, it's also temporal. It's these windows in time that truly dictate whether civilizations have a chance to survive. What this means is that even if a planet sits in the Goldilocks zone in space, it still needs to pass through a series of ideal conditions long enough and stable enough for life to evolve from simple organisms to complex beings, maybe even intelligent life. But the universe is never static. Stars change, cosmic radiation fluctuates, and geological shifts can push a planet out of its biological window. Take the Great Oxygenation Event on Earth, for example. It dramatically altered our atmosphere and opened a new window for complex life to develop. Yet there have also been harsh eras, ice ages, massive asteroid impacts that made conditions brutal and threatened life's survival. These periods could last millions or even tens of millions of years, enough time to weaken or wipe out entire species. Here's a lesser-known fact: it's not just planets, but whole star systems that go through cycles, violent gamma-ray bursts, fluctuations in their star's activity, all impacting the long-term habitability of life. So a biological window is really a complex dance of many factors, interacting over billions of years. Philosophically, this idea hits deep. If intelligent life only exists in fleeting moments compared to the universe's enormous age, then maybe we're just passing travelers, brief sparks of light in an endless night. Perhaps intelligent life emerges and fades repeatedly, leaving behind a silent void we're still trying to fill with signals from the cosmos. This raises profound questions about our own existence. Are we an inevitable part of the universe's story, or just a rare temporary phenomenon? And if we're just passing through, should we cherish every moment or try to stretch this biological window as far as we can? But these windows don't always slam shut just because of natural causes. There may be other forces at play, hidden dangers we haven't yet discovered, or physical laws we don't fully understand that threaten life. We can't rule out that it's not just time, but these unknown challenges that truly kill life. And as we gaze out into the cosmos, searching for companions in the vastness, the question lingers, echoing in our minds: if not time, then what else could bury life in this immense universe? Imagine standing beneath a vast, starry night sky, where billions of stars shimmer across the endless universe. Suddenly, one distant star flares up, shining billions of times brighter than our sun, and then explodes violently. This is a supernova, a colossal stellar explosion, marking the dramatic end of a massive star's life. It's an astronomical event so powerful, it could wipe out all life on a nearby planet in mere seconds. But a supernova isn't just a bright flash that fades away. It releases an immense amount of energy, blasting out cosmic rays and intense radiation, capable of destroying a planet's protective ozone layer. Without that shield, the surface gets bombarded with deadly ultraviolet rays. These explosions can also disrupt a planet's climate for years, even decades, plunging ecosystems into deep crisis. Yet there's something even more terrifying than a supernova, a gamma-ray burst, or GRB. These are incredibly powerful beams of gamma radiation fired out in narrow jets when a massive star collapses into a black hole. In just 1 second, a GRB can unleash more energy than our sun will produce over its entire lifetime. If such a burst were to hit Earth directly, it would trigger a global catastrophe rapidly and almost completely obliterating life. Here's a little-known fact. Scientists have found traces of past supernovae near Earth, possibly linked to mass extinction events in our planet's geological history. These clues remind us that supernovae aren't just distant cosmic fireworks. They're real threats that life on Earth has faced before. That said, there's still debate about how exactly these events impact life. Some physicists and biologists believe that although supernovae and gamma-ray bursts are deadly, ecosystems can bounce back and microbial life might survive underground or in ocean depths, eventually re-emerging. Others worry that these explosions act like resets, repeatedly interrupting the long, slow process of evolution and making complex life difficult to sustain over time. The sheer force of these cosmic events makes us wonder why long-lasting life, especially intelligent life, might be so rare in the universe. A simple, yet compelling reason is that life doesn't just have to overcome biological challenges, it must also survive the universe's wrath. These destructive cosmic storms, capable of wiping out entire civilizations without warning or mercy. Maybe intelligent life like ours is simply a lucky guest appearing in a fleeting window between supernova blasts and gamma-ray bursts. That thought only deepens the mystery of one big question. Even if life can endure these cosmic hazards, can the intelligence it produces avoid destroying itself? That's the question waiting for us to explore next, because maybe the greatest enemy isn't the distant stars, but the choices we make as we evolve and build our civilizations. Technology is like a magic key that unlocks countless possibilities for intelligent life, but it's also a double-edged sword. It can pave the way for incredible progress, yet just as easily bury a civilization in flames. When a society reaches a high level of technological advancement, it faces challenges unlike anything in its evolutionary history. Picture the earliest breakthroughs: fire, the wheel, then steam engines, electricity, the internet, and now artificial intelligence. Each invention pushes humanity forward, improving lives, exploring the cosmos, and expanding our knowledge. But with every leap come hidden dangers we couldn't have imagined before. Weapons of mass destruction, from atomic bombs to biological and chemical arms, can wipe out millions in seconds. Ironically, humans created these tools to protect themselves, yet these very inventions could bring about their own extinction. This isn't science fiction, it's a grim reality that has happened and remains a constant threat. Next is climate change, a consequence of over-exploiting resources and polluting our planet. A crisis modern humanity is grappling with more urgently every day. Climate models warn that without fundamental change, Earth could soon become inhospitable to complex life as we know it. On top of that, rapid advances in artificial intelligence open a new chapter filled with uncertainty. AI systems are becoming smarter and more autonomous, creating risks of losing control if left unchecked. Some scientists, philosophers, and engineers warn that AI might become an existential threat if it surpasses human oversight. All these factors combine into what's called the technological filter, a threshold every civilization must overcome to survive and thrive. If they fail, their own progress could wipe them out before they ever reach the stars. An interesting detail often overlooked is that this technological filter might not be just a single event or hurdle, but a series of complex overlapping challenges, from nuclear war and environmental collapse to global pandemics and the dangers of emerging uncontrollable technologies. Researchers still debate how to get past this filter. Some are hopeful that awareness and education will help humanity manage technology, wisely live in harmony with nature, and safeguard themselves from catastrophe. Others believe the risks are so great that only the luckiest, smartest, and most resilient civilizations will make it through. This deepens the mystery of why the universe feels so quiet and empty. If every civilization risks self-destruction or annihilation by the technological filter, then intelligent life may only flicker briefly within the vast timeline of the cosmos. But suppose a civilization does overcome all these challenges, what then? They might seek to break free from their planetary bounds, search for cosmic companions, or even transform their very nature to survive in the harsh, vast universe beyond. This is the story of pioneers explorers who push past fear and limits to open doors to unimaginable possibilities. And that's when we start asking new questions about our own future. Can we become a civilization that passes through the technological filter? And if so, which path will we choose? This journey isn't over, it's just beginning at this very moment as you listen to these words. The Kardashev scale is a bold idea, an ambitious way to measure civilizations based on how much energy they can harness. A Type 1 civilization can tap into and store all the energy available on its home planet. Type 2 steps it up by capturing the entire power output of its star. And Type 3, they wield the energy of an entire galaxy. This concept isn't just about raw power, it's a fascinating framework for imagining how civilizations might evolve beyond the limits of biology as we know it. Picture a colossal structure enveloping a star, something called a Dyson sphere, proposed by physicist Freeman Dyson. It's not just a simple shell or net, but a vast network or shell of satellites orbiting the star, capturing nearly all the energy it emits. With such an enormous power supply, a civilization could fuel technologies and projects far beyond anything we can imagine today. Beyond the Dyson sphere, there's another intriguing idea: star lifting. This hypothetical process involves siphoning off energy and material directly from the star to boost energy efficiency and even extend the star's lifespan. If a civilization mastered this, it wouldn't just survive, it could thrive sustainably for millions or even billions of years, an almost unimaginable stretch of time for us. Yet here's the puzzling part. Despite these theories being around for decades, we haven't found any solid evidence of Type 2 or Type 3 civilizations. No signals, no signs of gigantic energy harvesting megastructures, nothing that clearly shows a civilization capable of harnessing stellar or galactic energy on such a massive scale. Which leads to a tough question: if these civilizations truly exist and can survive for so long with such immense energy use, why is the universe so silent and seemingly empty? Are they deliberately hiding? Or do we simply lack the technology or understanding to detect their presence? Or maybe they just don't exist at all. Some hypotheses suggest that Type 2 or 3 civilizations might evolve in ways completely different from what we imagine, using energy and technology in forms that evade our current detection methods. They might have transformed into non-physical entities or shifted into other dimensions, making their presence undetectable by traditional astronomy. Scientists also debate how realistic Dyson spheres or star lifting really are. Building such colossal structures would require unimaginable resources and technology. Plus, would a civilization even want to consume all the energy from a star or galaxy? Maybe they'd prefer a more sustainable path, seeking harmony with the cosmic environment, rather than maxing out their energy use. Here's a fun historical note. The Kardashev scale was first proposed in the 1960s during the Cold War and the space race, a time when humanity dreamed of reaching far beyond Earth. Today, it still serves as a powerful theoretical tool to envision the future, but it also carries a quiet, bittersweet reminder of our loneliness in the vast cosmos. If such civilizations do exist and endure for millions or billions of years, they'd be like immortals among the stars, witnessing countless generations of stars born and dying in an endless cosmic cycle. It's a humbling and endlessly curious idea. So the big question remains: if these beings are out there, why haven't we found them yet? Are we just at the beginning of our search? Or is the universe holding a secret that only the most persistent explorers will ever uncover? That mystery opens the door to the next chapters in our grand adventure to understand the universe's deepest secrets. There's a hypothesis that sends a chill down your spine, a strange mix of curiosity, loneliness, and the eerie feeling of being watched. It's called the zoo hypothesis. Imagine yourself as a wild animal living in a nature reserve, carefully observed from afar, but completely unaware. Somewhere out there in the vastness of space, other civilizations might be watching us the same way, seeing Earth as a rare phenomenon, like a special species living in its own little habitat, preserved either for study or maybe just for their entertainment. Unlike stories about aliens making contact or invading Earth, this idea suggests something different, that we're left alone, undisturbed, with no direct interference. Think of a huge wildlife sanctuary deep in the jungle, where scientists observe animals through telescopes and cameras, never stepping in, never changing the population or environment. In the same way, the universe might have created a kind of preserve for us, where we live and evolve naturally, free from outside meddling. What's really striking is that this isn't just sci-fi speculation, it's based on a profound puzzle: the silence of the cosmos. The universe is unimaginably vast, with billions of galaxies, each holding billions of stars, many of which could host Earth-like planets. Yet we've never received a clear signal or sign from any other civilization. So if they exist, why don't they reach out to us? Maybe they're watching but deliberately staying silent, so as not to disrupt the natural course of life on Earth. Or perhaps they follow some kind of ethical code that forbids interfering with younger civilizations. Or maybe from their perspective, we're still too primitive, too chaotic, just a small performance, a simple play unfolding in a grand cosmic gallery. We're the actors, unaware of the mysterious audience, those silent watchers who supervise but never step onto the stage. This raises a mind-bending question. If our lives are just part of a program, a minor event in someone else's plan, what does that say about our true meaning? Do we really have free will, or are we simply following a script written for us? That thought can be unsettling, even a little heartbreaking, but it also opens the door to a deeper self-awareness about our place in the universe. Debates about the zoo hypothesis remain lively among scientists and philosophers. Some argue that if advanced civilizations exist and can observe us undetected, they probably have good reasons, like protecting the natural development of other societies or preventing cosmic diseases from spreading. Others counter that the idea is hard to prove and borders on science fiction. There are also controversial moments when humans detect strange phenomena, mysterious radio signals, or unexplained signs from space, sparking hope that silent watchers might really be out there. But so far, the evidence remains vague and far from conclusive. In this light, the silence of the universe becomes a huge mystery, like a foggy curtain draped over a vast forest where you only catch glimpses of shadow through the leaves. Maybe we really are residents of a giant cosmic zoo. Or maybe we're truly alone, drifting lost in the endless sea of time and space. And then you wonder, if that's true, will someone out there someday lift that veil of silence and invite us into a greater story? Or will we remain forever the uninvited guests in a theatre with no audience? The question is still open, guiding us toward deeper reflections on the nature of life and its meaning in this vast, mysterious universe. The universe, in its vast and silent expanse, often feels like an endless field under a quiet silver moon, empty still and stretching beyond what the eye can see. The idea of silentium universi, the silence of the universe, paints a haunting picture. Maybe we are truly alone, isolated in the immense void, with no other civilizations, no echoes of life beyond Earth. Imagine standing on a dark mountaintop at night. The only sounds are the wind and distant stars twinkling far away. That deep emptiness, that profound loneliness sinks in. For about 13.8 billion years, the universe has expanded and evolved. In that time, billions of stars have been born and died. Billions of planets have circled those stars. Yet here we are today, with no clear sign of life beyond our own planet. It's not just the absence of physical evidence, but an almost perfect silence across radio waves and electromagnetic signals. signals humans have been patiently searching for over decades. The big question is this vast emptiness truly empty? Or is there something hiding the existence of other civilizations? If not, then that silence isn't just a scientific puzzle. It's a profound symbol of our place in the cosmos. There's a deep sadness in realizing this solitude, like standing alone in an endless ocean with no one beside you. But alongside that sadness is a chance to reflect on ourselves, to find meaning in life, not by the presence of others, but through our own experiences, emotions, and actions. Throughout history, many astronomers have hoped and searched for signs of life beyond Earth. Yet despite advances from radio telescopes to gamma-ray detectors, the only answer has been silence. It's not an easy truth to face because humans are wired to seek connection, companionship in the vastness of space. Interestingly, Silentium Universi isn't a new idea. Philosophers and astronomers have debated for centuries whether those stars were vibrant cities of life or just cold, lifeless gas clouds. Today, with powerful modern tools, we've scanned millions of distant planets and still no cities found. This brings up a major debate in science. Is the universe really a quiet zone? Or are we simply not sophisticated enough to hear its voice? Some believe other civilizations might use signals beyond our detection, or choose silence, deliberately hiding to avoid unknown dangers lurking in the cosmic wilderness. That's why silence doesn't mean stillness. The universe is likely still moving, evolving in ways we don't fully understand, complex phenomena happening beyond our reach. Yet this silence serves as a mirror, inviting us to contemplate the preciousness of every living moment and the meaning of existence in a world with no guarantees of connection or eternity. And in that quiet void, maybe our stories, dreams, fears, and hopes are the most extraordinary wonder the universe has ever known. From solitude, we can create meaning, a story, without needing anyone else's presence. It's not just sadness, it's an invitation for you, for me, for all of us to make every moment count, even if it's just a tiny dot on the grand timeline of the cosmos. Imagine time as a river that never stops flowing, rushing endlessly downstream, never turning back. This arrow of time, guided by the fundamental laws of thermodynamics, carries us from order to chaos, from life toward the cold, dark death of the universe. You can almost feel the chill creeping in as the star's light fades and finally goes out, leaving the cosmos vast, cold, and silent, where all matter slowly breaks down and drifts apart. The concept of entropy, the measure of disorder, is one of science's deepest insights. It tells us that in any closed system, the total disorder never decreases. In other words, order doesn't arise by chance and will inevitably fall apart. The universe is like a book slowly tearing at the edges, its pages yellowing and drifting away, impossible to keep intact. Picture the universe as a room you try to keep tidy, but no matter how hard you clean, tiny specks of dust keep gathering. That's entropy in everyday life, a constant tug toward disorder. Scientists from Boltzmann to Hawking have spent lifetimes unraveling how entropy works, and through their work, they predicted the universe's chilly fate, the so-called heat death. After trillions of years, energy will be spread evenly across space, with no hotspots left to sustain life or any form of order. Every star will burn out, every planet become lifeless, and even memories of us will fade away, vanishing like whispers lost in time. It's like a gentle melody, slowly fading to silence, a story with no final chapter as each page dissolves into the fog of eternity. It's natural to feel a pang of sadness, realizing that everything we know and love might be just a fleeting moment destined to dissolve into nothingness. Yet there's a strange and fascinating question that challenges our understanding. Is time truly just a one-way street? Some modern physics theories, especially in quantum mechanics and multiverse ideas, suggest time might be reversible, or that the universe could be reborn in new cycles where order rises again from chaos. This opens the door to ideas that sound almost like science fiction, that heat death might not be the absolute end. The universe might not be a one-way flow, but a continuous spiral, an endless cycle of creation, destruction, and rebirth. Take a moment to imagine that every ending we fear could actually be a new beginning within a vast cosmic cycle we have yet to fully grasp. If time can flow backward, if chaos can turn back into order, then our role as tiny, fleeting creatures on a small planet might take on a whole new meaning. We are not just moments flickering out in the ocean of time. We might be the first witnesses to a universe, waking up a universe that can rise again from the ashes of heat death. And so, the eternal flow of time becomes not just a cold ending, but an invitation to wonder, to explore, and above all, to hope. Imagine a universe where space isn't limited to just the 3 dimensions we know, but also includes a dimension of time that can bend, twist, or even flow backward. In theoretical physics, scientists don't just study an expanding cosmos, they also explore the fascinating possibility that time itself might be reversible, giving rise to parallel universes or alternate timelines running alongside our own. Quantum physics and general relativity have unlocked doors that once seemed reserved for science fiction. One of the most intriguing ideas is about antimatter and time reversal. In some theories, antimatter isn't just opposite matter, it can be thought of as matter moving backward through time. So if you observe an antimatter particle, it's like watching a regular particle journeying into the past. This perspective challenges our very understanding of time and raises the question, could there be parallel universes where time flows in the opposite direction compared to ours? In those worlds, moments like ours might unfold differently, or even repeat endlessly in an infinite cycle. Picture watching a movie played in reverse where every action and event happens backward, but with an entirely new meaning. The strange thing is, these ideas aren't just speculation, they're grounded in advanced mathematics and physics. Multiverse theories suggest our universe might be just one among countless others, each with its own physical laws and distinct timelines. Somewhere out there, time might be flowing backward, or at least not following the familiar arrow of time we experience. The implications of these theories are profound. If time can reverse or loop, then the moments of our lives aren't one-off events that flash and fade, but parts of an eternal cycle. This notion can bring a quiet comfort, reminding us that our small selves might never truly vanish, but exist forever in another form, while also forcing us to grapple with tough questions about free will and destiny. Yet the debate among physicists is far from settled. Some argue these reversed time dimensions are just mathematical curiosities, not realities we can actually experience. Others believe these discoveries could be the first steps toward unraveling the deepest nature of the universe, and time itself a breakthrough that might forever change how humanity sees itself. Amidst this vast mystery, you might wonder if everything can repeat. Are we trapped in an endless loop? Or is this life just a one-time journey through time? This question opens a door to endless imagination and to some of our most profound beliefs. And then, stepping beyond even time's reversal, we might dare to ask an even bolder question. What if everything we experience our lives, our moments, are just part of a simulation? A gigantic computer program created by some entity or civilization beyond our understanding? It's a compelling, controversial idea that opens a whole new chapter in our quest to understand what it really means to exist. Have you ever paused, staring at your computer or phone screen, and wondered if everything you're experiencing, the world around you, or even yourself, might actually be part of a massive computer program? A simulation so advanced that no one could tell what's real and what's not. This idea isn't just a plot from sci-fi movies like The Matrix. It's a serious hypothesis debated by philosophers and scientists alike, with Oxford philosopher Nick Bostrom being one of its most notable proponents. Bostrom argues that at least one of these 3 possibilities has to be true. Either humanity will go extinct before reaching the technology to create such advanced AI simulations, or highly developed civilizations simply aren't interested in running simulations of their history or intelligent beings. Or we are in fact already living inside a simulation created by a super advanced civilization. Doesn't it feel a bit strange hearing this? The thought that every moment of your life, Every feeling, every thought could just be data processed by some gigantic supercomputer somewhere far beyond our reach. And if it's all a simulation, where does it begin? And where does it end? There could be technical limits in this system, like caps on how many characters or events it can handle, or glitches that occasionally make things seem off. Even the physical laws we call the laws of the universe might just be programming rules designed into the system. There are so many details that make us pause and think unexplained phenomena. In physics, small inconsistencies in human perception which might hint that this reality isn't quite complete. Those glitches could show up as strange events, cosmic oddities, science can't explain, or even supernatural experiences, which from this perspective might be bugs in the code. The implications of this hypothesis are profound and sometimes a little unsettling. If you're part of a simulation, what does that mean for life's meaning, free will, or even death? Your existence could be switched off anytime by unseen programmers. Or maybe you're just a character in a grand story, where the storyteller controls everything. But this doesn't have to lead to despair. On the contrary, it can open a new way of seeing existence like an artistic game, where every small action contributes to a bigger masterpiece, with purposes we might not yet understand. Just like a painter creating a digital masterpiece, pixel by pixel, or a composer writing a symphony, maybe we're part of an incredibly intricate and beautiful work of art. Of course, there's plenty of debate. Some scientists reject this idea, saying there's no concrete evidence we live in a simulation and that the universe we observe feels too real to be a mere model. Meanwhile, supporters point to the rapid advances in technology, especially AI, and say that building near-perfect simulations will be possible in the not-too-distant future, so we can't rule out the possibility we're already inside one. Between the vastness of the cosmos and the smallness of ourselves, the simulation hypothesis opens a whole new dimension, a mirror reflecting our deepest questions about the nature of reality and the meaning of life. Whether real or simulated, your experience and awareness are the most certain and precious things you hold. And right now, as you listen or read these words, take a moment to feel that existence may be just a part of a greater program, yet exactly what gives your life meaning in this vast ocean of time.